Good afternoon, all. Today we'll be taking a question on risk using Ican performance management past question for May 2023, question 2. This is the second video based on requests. So the question will be read and we'll provide a solution to the question in as simple way as possible.
The local football club has asked for your advice on the number of programs that should be printed for each game. The cost of printing and production of programs for each game, as quoted by the local printer, is 1 million naira plus 400 naira per copy. Advertising revenue, which has been agreed for the season, represents 800,000 naira for each game. Programs are sold for 150 naira each. A review of sales during the previous seasons indicates that the following pattern is expected to be repeated during the coming season of 50 games. All figures assumed to be correct. Programs not sold at the game are sold as waste paper to a paper manufacturer at 100 naira per copy. Assuming that the four quantities listed are the only possibilities, you are required to A. Prepare a payoff table. B. Determine the number of programs that would provide the highest profit if a constant number of programs were to be printed for each game. C. Explain why you should buy 30,000 or 40,000 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. D. Calculate the profits which would arise from a perfect forecast of the numbers of programs which would be sold at each game. E. Discuss the major limitations at expected value criterion in decision making.
Okay, so we provide a solution to the question. They said in the question here you can see number of programs sold 10,000, 20,000, 30,000, 40,000. We have number of games. The number of games provided there will help us get the probability that will be attached to the equation. So let's start with the criteria. Criteria represents how many units you want to produce. Let's assume we are producing 10,000, 20,000. We test each of the scenarios, 30,000, 40,000. That is because their demand, as stated in the equation, they say they have a demand, which is the number of games. They have a demand of 10, 20, 30, and 40,000, which you can see in the equation. So we can either print or produce. So print or produce 10, 20, 30, or 40. Then on the other side, we will talk about the demand. Demand will also include the probability. So the demand can be 10,000 units, it can be 20,000 units, it can be 30,000 units, it can be 40,000 units. So any of these can be our demand. So the payoff matrix is in this form, which is the A. So we need to find out all the values associated here. So for the probability, they clearly told us that they have number of games. You have number of games here. Number of games, you have 5, you have 20, you have 15, I will have 10. And the summation of the number of games, 15 plus 5 is 20, plus 20 is 40, plus 10 is 50. So total number of games is 50. Total number of games is 50. Now the probability for the 5 game will be 5 over 50. 5 over 50 is 0.1. So that is our probability here, 0.1. We also have 20 over 50. 20 over 50, 20 over 50 gives us 0.4. 20 over 50 gives us 0.4. So here is 0.4, which is the probability. We only have 15 over 50. 15 over 50. 15 over 50 gives us 0.3. So 0.3. Then here, we equally have 10 over 50. 10 over 50 10 over 50 gives us 0.2. So we have the full set of probability. If you sum them up, we now have 1. So these are the probabilities. Now we need to get all the values under this criteria. Then we'll apply our probability on them and get our values in thousands. From there we can make our decision. So I'll wipe here so I can paint the scenarios under each one. I will take scenario 1. Scenario 1, when we have print 10,000 units. So scenario 1, print 10,000. So if we are printing 10,000 units, what values will we have in terms of profit or loss? If it's a loss, this will be a cost table. Cost/profit table. So if it's a loss, it will be a cost table. If it's a positive value, it will be a profit or profit payoff table. So they asked us to prepare a payoff table, which we have done here. So we start with scenario 1, print 10,000 units. Their demand here is 10,000 units, 20,000 units, 30,000 units, 40,000 units. That is their demand. Now, I will need to find my sales as well. So sold, if I'm printing 10,000 units and I'm demanding 10,000, meaning I can sell 10,000. If they are demanding 20 and I printed 10, I can only give them 10. They are demanding 30, I printed 10, I will only give them 10. They are demanding 40, I printed 10, I will equally only give them 10. So I will give them 10,000 in each of the scenarios. So my sales remains 10,000. Then unsold. Need to find my unsold. There is no unsold here. I printed 10,000, they demanded 10,000. No unsold. Here, no unsold as well. Because they demanded 20 and I gave them 10. No unsold here, and equally no unsold. So there is no value for unsold. Then we need to get our sales revenue. Sales revenue. Our sales revenue is simply the quantity that we have sold multiplied by, in our question here they told us programs are sold for 150 naira each. That is what they say, 150 each. So quantity times 150. Quantity times 150. So quantity times 150, 10,000 times 150 gives us 1,500,000. So here I have 1,500,000. And since the 10,000 is constant all through, I still have 1,500,000 in all. 1,500,000. 1,500,000. So that is my sales revenue. Recall that we'll have a waste revenue. That is if there is a waste. So I can just create that waste revenue. Waste revenue is simply B, the quantity unsold, QU, times, there is a price per unsold quantity, as I've told us here. They say programs not sold at the game are sold as waste paper to a paper manufacturer at 100 naira per copy. So this is times 100 naira. So quantity unsold here is 0. So all through will have waste revenue as zeros, all through. We also have total revenue. Total revenue will be our ad revenue plus all of these other revenues we might have generated. So total revenue is simply my ad revenue, ad plus other revenues. Ad plus other revenues. Our ad, as I've told us here, they said that advertising revenue, which has been agreed for the season, represents 800,000. So 800,000 is our ad revenue. Our ad revenue, assuming there was revenue here, would have added this plus our ad revenue to get our total revenue. But we don't have any value under waste revenue. So we only add this, our sales revenue, plus our ad revenue. Clearly here, our sales revenue is 1.5 million, 1,500,000 plus 800,000. It gives us 2,300,000. So our total revenue here is 2,300,000. And it's constant all through. 2,300,000, 2,300,000, 2,300,000. We've gotten our total revenue. For our cost, for cost, then we now talk of profit or loss. And the profit slash loss. For cost, they told us in the equation that we have 1 million plus 400 times quantity printed. 1 million, which is fixed, plus 400 times quantity printed. Here, the quantity printed is 10, because we are saying 10,000 units as quantity printed. So, we'll have that 10,000 times 400 will give us 4 million. 4 million plus 1 million will give us 5 million. So 5 million here is our cost. 5 million is our cost. 1 million plus 400 times quantity printed. So 5 million, 5 million, 5 million. Our cost is 5 million. You can clearly see that our cost is greater than our revenue, which gives us a loss. So 5 million minus 2,300,000 will give us 2,700,000, which is a loss. So 2,700,000 loss. 2,700,000 minus 2,700,000 minus 2,700,000 minus 2,700,000. So that's a loss. 2,700,000 loss. Although I told you that this is a cost or profit table, so these are cost values instead of profit, is a loss. I'll bring them here ignoring the negative sign, since I've said it's either cost or profit. So I have 2,700,000. I think I'll just put up zeros here to make the work a bit shorter in terms of values. So 2,700,000 I will now put as 27. We've done that for 10,000 when 10,000 is printed. So we'll take scenario 2 when 20,000 is printed. Scenario 2 when 20,000 is printed. Scenario 2 if 20,000 is printed. Their demand still remains 10,000, 20,000, 30,000, and 40,000. If 20,000 is printed, they are demanding 10,000. I can only sell 10,000. I can't give them more than what they want. If 20,000 is printed and they are demanding 20,000, I can sell the 20,000. If 20,000 is printed and they are demanding 30,000, I can't give them what I don't have. So I will only give them the 20,000 I have printed. The same thing goes to this. I can only give them the 20,000 I've printed. I can't give them more than what I've printed. So here, the quantity unsold should be, I printed 10,000, they demanded for 10,000. I printed 20,000, they demanded for 10,000. I gave them the 10,000 that I printed, meaning I will have a quantity unsold of 10,000 here. So there is quantity unsold. Then here, I sold the whole 20,000. There is no unsold. Here I sold the whole 20,000, no unsold. I sold the whole 20,000 here, no unsold. So the sales revenue is quantity sold times 150. Quantity sold times 150. So 10,000 times 150 will give me 1,500,000 as we have calculated initially. 1,500,000. 20,000 times 150, it will be double of this, meaning I'll be having 3 million. 3 million. 3 million. Quantity unsold times 100 will give us waste revenue. Quantity unsold here is 10,000. So 10,000 times 100 will give me 1 million. 10,000 times 100 gives me 1 million. Here there is no quantity unsold. So 0, no quantity unsold, 0, no quantity unsold, 0. Total revenue is the add revenue plus other revenues. So the revenues I have here, I have sales revenue, I have waste revenue plus add revenue. So 1.5 million plus 1 million will give us 2.5 million. Plus the add revenue of 800,000 gives us a total of 2 million, 3, gives us a total of 1 million plus, 1.5 million plus 1 million, 2.5 million, plus 800,000 will give us, let's see, 2.5 million, 2,500,000 plus 800,000 gives us 3,300,000. So this is 3,300,000. I'll check through for this. I have 3 million naira here for sales revenue. There is no waste revenue. So I'll put the add revenue to it. So 3 million plus add revenue of 800,000 give us 3,800,000. Here is the same as 3,800,000. 3,800,000. Now we'll go to the cost. The cost is 1 million plus 400 times quantity printed. Quantity printed here is 20,000. So 20,000 times 400 will give us 8 million plus 1 million will give us 9 million. 400 times 20,000 gives us 8 million plus 1 million gives us 9 million. So it remains 9 million all through here. 9 million. 9 million. 9 million. So cost is 9 million all through. Then the difference between the cost and the revenue, you can clearly see the cost is also higher than the revenue here. So 9 million minus 3,300,000 will give us 5,700,000 in negative, minus 5,700,000, so it's a loss. Then we'll have 9 million minus 3,800,000 will give us 5,200,000 in negative, minus 5,200,000, minus 5,200,000, minus 5,200,000. So these are the values we have. Since there are losses, I told you this is a cost table, so I won't bring in the negative here. I will only indicate they are all costs. 5,700,000, so 57. Here I have 52. Here I have 52. Then here I have 52. I've calculated for the scenario under when 20 units are printed. We'll go to scenario 3, when 30,000 units are printed. When 30,000 units are printed. Scenario 3. If 30,000 units are printed, with what we are taking before, they are demanding 10,000. I can only give them 10,000. It simply means I will have quantity unsold of 20,000 because I printed 30,000. Here, I printed 30,000, they demanded for 20,000. I will give them the full 20,000 they demanded. But I will have a quantity unsold of 10,000. Here, I will give them the entire 30,000 they demanded. I will have no quantity unsold. Here, I will give them the 30,000 I printed. I can't meet up their demand. There is no quantity unsold. Then, we proceed to compute for the sales revenue. The sales revenue, we have the quantity times the price per what unit sold. So 150 times 10,000 gives us 1.5 million. 1,500,000. We have 150 times 20 is double of this, so I have a 3 million. 1 million times, 150 times 30,000 units. 150 times 30,000 units. 150 times 30,000 units. I have 4,500,000. 4,500,000. This will still be, because this is still the quantity sold, 4,500,000. Now the quantity unsold, which is the waste. We talked about the waste. Here we'll have an unsold quantity of 20,000. 20,000 times 100 will give us 2 million. We also have 10,000. Yeah, 10,000 times this will give us 1 million. Then here, no unsold. Total revenue will simply be our sales revenue plus waste revenue plus our advertisement revenue. So the summation 1.5 million plus 2 million plus 800,000 will give us 4,300,000. So this is 4,300,000. 3 million plus 1 million plus 800,000 will give us 4,800,000. 4,800,000. Then we'll have 4.5 million. There is no waste revenue. So 4.5 million plus 800,000, which is the ad revenue, will give us 5,300,000. So it's still the same with this. 5,300,000. And here we'll only have 5,300,000. Now we have gotten the total revenue, we'll treat the cost. The cost, they say 1 million plus 400 times the quantity printed. Quantity printed in this scenario is 30,000. So 30,000 times 400 will give us 12 million. 12 million plus 1 million will give us 13 million. So it will be 13 million all through. 13 million, 13 million, 13 million, then 13 million. So 13 million all through. Then the profit or loss is the difference between the cost and the total revenue. The cost is also higher than the total revenue here. So the first value is 13 million minus 4,300,000. 13 million minus 4,300,000 will give us a loss of 8,700,000. A loss of 8,700,000. 13 million minus 4,800,000 will give us a loss of 8,200,000. 8,200,000 loss. 8,200,000 loss. 13 million minus 5,300,000 will give us a loss of 7,700,000. So minus 7,700,000 minus 7,700,000. The two of them. So we can now put this in here. We have 87. 87. We have 82. We have 77. Then we'll have 7. Now we'll take the last scenario. The last scenario. Oh, why do the wrong side? The last scenario is to print 40,000 units, and that is scenario 4. Print 40,000 units. Print 40,000 units, which is scenario 4. Scenario 4. Okay. If I'm printing 40,000 units, I can meet their demand of 10,000. But I will have an unsold unit of 30,000. If I'm printing 40,000 units, I will meet their demand of 20,000, but I will have an unsold of 20,000. If I'm printing 40, I will meet their demand of 30,000, leaving me with an unsold of 10,000. Then here I will meet their demand of 40,000. Then there is no unsold. Now we'll compute the sales revenue. The sales revenue here, we have 10,000 times 150. That will give me 1,500,000. This will give me 3 million. This will give me 4,500,000. That is 30,000 times this. Then this will give me 6 million. So I've gotten the sales revenue all through. Then the waste revenue. Waste revenue, I have the quantity unsold times 100. So here quantity unsold is 30,000, which will give me 3 million. Quantity unsold here is 20,000, which will give me 2 million. Quantity unsold here is 10,000, which will give me 1 million. Then here there is no quantity unsold, 0. We have the total revenue to be ad revenue, advertisement revenue plus other revenues. So 1,500,000 plus 300 plus 3 million, 1,500,000 plus 3 million plus advertisement revenue of 800,000 will give me a total revenue of 5,300,000. 5,300,000. 3 million plus 2 million plus advertisement revenue of 800,000 will give me 5,800,000. 4.5 million plus 1 million plus the advertisement revenue of 800,000 will give me 6,300,000. Then 6 million, there is no waste revenue here, plus the 800,000 in advertisement revenue will give me 6,800,000. Then we'll go to the cost. The cost, they said, is 1 million plus 400 times the quantity printed. The quantity printed here is 40,000 units. So 40,000 units times 400 will give me 16 million. 16 million plus 1 million will give me 17 million. So here is 17 million. All through 17 million. 17 million. 17 million. Then the profit or loss. 17 million, which is cost, minus 5,300,000. 17 million minus 5,300,000 gives us 11,700,000 in negative. 11,700,000 in negative. 17 million minus 5,800,000 gives us 11,200,000 in negative. 11,200,000 in negative. 17 million minus 6,300,000 gives us 10,700,000 in negative. 10,700,000 in negative. 17 million minus 6,800,000 gives us 10,200,000 in negative. 10,200,000 in negative. So I'll put our values here. 11,7, 11,2, 10,7, 10,2. Okay, Since we are done with each of these scenarios, we will apply the probability. The question clearly says we should prepare a payoff table. Which you have done, but you have not considered the probability yet. So we need to consider the probability. I'll bring in the probability. So criteria, 10,000, 20,000, 30,000, 40,000. The demand, recall that there is probability of 0.1, 0.4, 0.3, 0.2. They will have demand 10,000, 20,000, 30,000, 40,000. Remember, this is in thousands, so I'll say this is in thousands. I'll consider the probability now. 0.1 times 2007, just as I say here, it's in thousands. 0.1 times 2007 will give us 270. 0.1 times 2007, 0.1 times 27 will give us 270. So it's 270 all through here. 270, 270, 270. 0.4 times 57. 0.4 times 57 gives us 2280. 2280. 0.4 times 52 gives us 2080. 0.4 times 52 is still 2080. Here is also still 2080. So that has been captured. Then 0.3 times 87. 0.3 times 87 is 2610. 2610. 0.3 times 82. 0.3 times 82 gives us 2460. 2460. 0.3 times 77. 0.3 times 77 gives us 2310. 2310. And I also still have 2310. Then lastly, 0.2 times 11.7 gives us 2340. 2340. 0.2 times 11.2 gives us 2240. 2240. 0.2 times 10.7 gives us 2140. 2140. Then 0.2 times 10.2 gives us 2040. Now, this is my payoff matrix, and I've been able to attempt their question, their A part. So this is the payoff matrix. I've fully considered the probability. So I've answered the A part of that question that said prepare a payoff table. So that is the payoff table. So the B part says determine the number of programs that would provide the highest profit if a constant number of programs are to be printed for each game. If a constant number of programs are to be printed, if a constant number of programs we are to be printed for each game. So looking at this, I will consider the maximus decision because we are trying to maximize our revenue, or in this scenario where there is cost. Maximus decision, which is maximum of maximums. I will use maximus criteria. So I'll use maximus. Maximus. Maximus simply means maximum of maximums. Maximum of maximums. Recall that these are negative values. All of them are negatives. So the smallest negative value is usually the highest negative value. The smallest negative value is the highest negative value, meaning the closer a number is to 0 from negative, the higher the number. So what it means, out of all these things you are saying here, 270 is the highest because it is the one that is closest to 0, and they are all in negative. So this is a loss table. It's a loss table. It means all values are in negative. So if I'm considering maximus, I have 10,000, I have 20,000, I have 30,000, and I have 40,000. What is the maximum value here? The maximum value is still 270. The maximum value here, maximum value, recall that as long as it's a negative value, the maximum is usually seen as the smallest since it's negative because it's the one that is closest to 0. Maximum here now is 2080. Maximum here is the smallest, which is closest to 0, which we are saying here 2310. 2310. Maximum here is 2040 because it's the closest to negative. Now we have gotten each of those are maximums. But what they told us is maximum of maximums. Out of all these maximums I have now, which one is the highest? This is my maximum. So using maximum of maximum, we are going to print 10,000 units. Using maximum of maximum, because these are maximums, then inside these maximums, we chose a maximum. This 270, because it's a negative, is the highest value out of all of this. So the decision will be print 10,000 units, because it has the least negative value. And you know that having a least negative value means a tendency of having a higher positive value or a tendency of having a higher profit. So the decision is print 10,000 units. Print 10,000 units. And you saw the number of games there. For print 10,000 units, they told you 5 games. So you will go with that. Print 10,000 units, which is 5 games. So we have answered that B part of the question. The C part says, explain why you should buy 30,000 or 40,000 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. Now, I'll just get that to you. Is a theoretical part. The production or printing of the programs involves incurring fixed costs, which they have stated in the question. The larger the volume printed, the lower will be the cost of printing per copy. Therefore, printing 30,000 or 40,000 copies will be an optimistic decision, informed by the need to maximize the benefit that is derivable from the fixed cost of printing. Now, in order to reduce that fixed cost of printing, it means printing more in order to cover for that fixed cost. The fixed cost they told you is 1 million. If I print more, it will reduce my fixed cost. So that is what they are talking about. Since I print more, it reduces my fixed cost. Then the D part says, calculate the profit which would arise from a perfect forecast of the numbers of programs which will be sold at each game. Now I will find out that. The C part of the question, the maximum profit is the D part. Profit will have profit without perfect information. They will have profit with perfect information. Profit without perfect information and profit with perfect information. Without perfect information, that person here will be looking for a way. Out of print 10,000, he will be looking for the smallest. Since it's a loss. Out of print 10,000, in print 10,000, the smallest is 270. So here I will have, without perfect information, 270 plus, under print 20,000, he will look for the smallest as well, which is 2080. 2080 plus, under print 30,000 units, you will look for the smallest as well. The smallest here is 2310. 2310 plus, under print 40,000, you also go to the smallest, which is 2040. Remember, there are losses, so he's trying to reduce the loss as much as possible. So I'll add up those four numbers. I have 270 plus 2080 plus 2310 plus 2040. That gives me 6,700. Remember, it's a loss. 67. That should give me, you remember that the thousands as well. Now, with perfect information, I will pick only the losses. With perfect information, I will pick only the losses. Only that smallest loss. That's what I mean. With perfect information, whether they are demanding 10,000 or they are demanding 20,000 or they are demanding 30 or 40,000, you will go with the smallest. That is perfect information. So what it means is 270 all through for all the scenarios. 270, 270, 270 for all scenarios. Then I will add them together. 270 plus 270 plus 270 plus 270 gives me 1,080. 1,080. You can see that with perfect information, without perfect information, I would have incurred a loss of 6,700. But with perfect information, I'm only incurring a loss of 1,080. Now the difference is a profit. That difference of 6,700 minus 1,080 will give us 5,620. 5,620. It's just like cost savings. We call it cost savings. It's a profit. You have saved that cost. It's a cost we would have incurred, but we have saved it. If without information we are getting this, with perfect information we are getting this, we have saved the cost of this, which is our profit. I've answered that D part. The E says, discuss the major limitations at expected value criteria in decision making. Now I will just list them. Under expected value criteria, it depends on subjective probability. Just as what you are saying here, it depends on the subjective probability that have been assigned by the person solving it. So it might not be 100% correct. Then it also is only useful for repetitive outcome and not for one-off outcomes. Then thirdly, the expected value might not be one of the possible outcomes. It might be, what will come out might be entirely different from the expected value outcome that you have gotten. It does not give a view of the risk involved. It doesn't show you the risk involved. That's what I say. Expected value does not show you the risk involved. Then it is a weighted average of all possible outcomes. It is a weighted average, which is what they are saying here. Weighted average. You can see if you sum up all this, it gives you one. So each works with a weight. So it's a weighted average of all possible outcomes, which is a limitation. So with this, we have come to the end of this particular video session. I hope you find this video useful in preparation for your Ican performance management. It can also be useful for those doing financial management. Thank you very much for your time and see you next time.